Hello guys, my name is IBM and today I gathered the courage to record some content for my IGCSE students. This content is specifically for IGCSE students who are doing physics. My name is IBM and this is going to be IGCSE physics. The topic I want to deal with today is going to be space physics. Space physics for IGCSE. Just remind you of the course outline for those of you who are doing IGCSE. You're supposed to study motion, forces, and energy as your first topic. You study thermophysics. You must have studied waves by now. You must have studied electricity and magnetism, or you should be preparing to study electricity and magnetism. You must have studied nuclear physics and space physics. When you're done with these 6 topics, I think you'll be ready for IGCSE physics. So let's go to space physics because I'm concentrating on space physics in these videos for my students as a way of reducing on the teaching time in class. So this is space physics and this is IGCSE and this is going to be lesson. I think this is going to be lesson 1 of space physics. There could be more. There could be 4 or 5 lessons depending on how much time I'll be having. But I'll try my level best to make sure that there are only 4 lessons, each of about 1 to 2 hours or 1 to 1.5 hours. Okay, so let's first go to the introduction part. In space physics, we are going to study 4 major important areas. One of them is the Earth. We shall talk about the Sun as a star. We shall talk about stars in general. We shall talk about the universe, and I think we shall talk about the solar system. So we are starting in chapter 6.11. We are going to start with the Earth. We're going to start with the Earth. And under the Earth, I just quoted this from the syllabus. I quoted the learning objectives from the syllabus. We should know that the Earth is a planet that rotates on its axis, which is tilted once in approximately 24 hours, and use this to explain observations of the apparently daily motion of the sun and the periodic cycle of day and night. We should know that the Earth orbits the sun once in approximately 265 days, and use this to explain the periodic nature of the seasons. We should know that it takes approximately 1 month for the moon to orbit the Earth, and use this to explain the periodic nature of the moon's cycles of phases. We are supposed to define average orbital speed from the equation v equals 2 pi r over t, where r is the average radius of this orbit and t is the orbital period. And we should recall and use this equation. Unfortunately, in the lesson 1, I will not discuss this equation under the Earth. I will be discussing this equation under solar system. I think that will be lesson 2. So let's start lesson 1, the Earth. So the first objective was telling us to be able to know that the Earth is a planet that rotates on its axis, which is tilted. It orbits once in approximately 24 hours. This animation here shows what exactly I will be talking about in this lesson or on this slide. The Earth is a rocky planet. Of course, we know that the Earth is rocky, just like other rocky planets that we shall talk about. Sometimes it is said to be terrestrial because it is solid in nature or rocky in nature. So the Earth is a rocky planet. The Earth is a rocky planet that rotates in a near, it is not perfectly circular, but is a near circular orbit around the Sun. And the Earth is believed to rotate on its axis, which is a tilted imaginary line through the North and South Pole, as demonstrated here. So there is an imaginary line which is slightly tilted at an angle of around 23.5 degrees to the vertical through the North and South Pole. So if this is the North and this is the South, it is believed that the Earth spins on this. The Earth spins or the Earth rotates on its axis, which is a tilted imaginary line through the North and the South Pole. And the axis of tilt I've demonstrated is approximately 23.5 degrees from the vertical. And because the Earth rotates, this rotation is going to be responsible. This rotation about its axis is going to be responsible for what we shall call days and night. However, it takes about 24 hours to make one complete revolution around about its axis. So we are saying the Earth completes one full rotation or one revolution in approximately 24 hours. And we always think, or we always assume that 24 hours is equal to 1 day. That is, half day is night, half day is day, is actually broad daylight. So the rotation of the Earth about its axis creates the apparent daily motion of the Sun as if it is rising and setting. Because the Earth spins about its axis, which is tilted at around 23.5 degrees, the rotation of the Earth about its axis creates the apparent meaning it is not actually true, but we get an impression as if the Sun is rising and it is setting in the evening, simply because the Earth is spinning about its axis. So this rotation leads to what we call day and night. So we have day and night because the Earth spins about its axis, or the Earth rotates about its axis in making one revolution in a time of about 24 hours. Therefore, half of the 24 hours is going to be day, and half of the 24 hours is going to be night, because half of the 24 hours might be facing the sun, and half of the 24 hours the Earth might be facing away from the sun. So this creates what we call day and night. So let's talk about day and night in more details. So how do we have day and night? How do we have day and night? So these diagrams or this animation here shows how we come up with day and night. So the rotation of the Earth about its axis is therefore responsible for the periodic cycle of day and night. So it's the rotation of the Earth about its axis. Remember, the axis is tilted at an angle of about 23.5 degrees. So it is this axis, it is this rotation which is responsible for day and night. So at any moment, half of the world is in daytime and half of it is in nighttime. Because many times half of it is always facing the sun and half of it is always facing away from the sun. So day is experienced by the half of the Earth's surface that is facing the sun. For example, in this diagram, if this is the sun and this part of the earth is facing the sun, so in this part of the earth which is facing the sun, it is going to be day. The other part behind the sun is going to be night. So day is experienced by that half of the earth's surface that is facing the sun, and night is experienced, or night is the other half of the earth which is facing away from the sun. So the other side which is facing away from the sun is going to be night, and the other part of the earth which is facing the sun is going to be day. And the cycle continues in a time of 24 hours, where the first 12 hours or approximately 12 hours could be day and approximately 12 hours could be night. Sometimes day could be longer than night, but the total could be approximately 24 hours. So the sun rises from behind the earth on the east. The sun rises from behind the earth on the east and sinks below the earth in the west as the earth rotates from west to east. So we expect that the earth rotates from west to east. The earth is expected to, or is seen to be rotating from west to east. So an observer who is on the earth's surface would therefore see the opposite, as if the sun is rising from east to west, because the earth is rotating from west to east. So the observer on the earth's surface will first see the eastern side of the earth, or will first see the sun as if it is coming from the eastern side, and therefore we believe that as the earth spins from west to east, the sun is expected to rise, or is believed to rise from east to west. But remember, this is just apparent, it's just an impression. It is not actually the truth, because the earth rotates from west to east. we see as if the sun is rising from east and it is going to be setting to the west. So in summary, we just believe that the sun rises from east and sets to the west. And therefore the earth, and this is because the earth rotates from west to east about its axis. So we should note these two differences. Because the earth rotates from west to east, then we believe we are free to agree that we are free to agree that the sun rises from east and sets to the west. This is the same concept you have always considered ever since you were young. You have always said that the sun rises from the east and sets to the west, but you did not know why it is said to be like that. But I think it's because the Earth rotates from west to east. Therefore, an observer on the Earth's surface, as the Earth rotates from west to east, sees the sun rising from east and setting to the west. One important thing we need to note from this: when the Earth's rotation on its axis makes the sun to look like it moves from east to west, it is the Earth's rotation on its axis, which is from west to east, which makes the sun to look like it moves from east to west. So it is an apparent observation. At the equinox, the sun rises exactly in the east and sets exactly in the west. That is at the equinox. What do we mean by equinox? Equinox means equal night. This is when day and night are approximate of equal length. So during equinox, where a day and a night are almost equal, the sun is observed to rise exactly from the east and setting exactly to the west during equinox. But of course, this may not be the same case during summer and during winter. However, the exact locations of where the sun rises and sets changes throughout the seasons. For example, in the northern hemisphere, half of the earth, of course, when we talk about the northern hemisphere, that is half of the earth which is above the equator, and the southern hemisphere is the other half of the earth which is below the equator. Of course, the equator is a point where the angle of incidence of light from the sun does not change. It's always the same throughout the year. So in the northern hemisphere, that is half of the earth above the equator, uh, in summer the sun rises north of east and it sets north of west. So during the summer, the sun rises north of east and it sets north of west. That is in the northern hemisphere. And this is because the nights and days are no longer equal during that time. And also in the winter, the opposite happens. In the winter, the sun rises south of east and sets south of west, as shown in this diagram here. So during winter, this is what they observe. The sun rises south of east. So if this is the east, the sun rises south of east and it sets to south of west. But in general, we just simply say the sun rises from the east and sets in the west. So though the approximate area changes throughout the year, we generally say that the sun rises in the east. The sun rises in the east and sets in the west. So in general, we say the sun rises in the east and sets in the west. So let's talk about the Earth's orbit about the sun. The Earth's orbit about the sun. The Earth's orbit about the sun. So I think we have already answered the first objective, which was to know that the Earth is a planet that rotates on its axis, which is tilted once in approximately 24 hours. And we have used this to explain observations of day and night, or the observations of the apparent daily motion of the sun and the periodic cycle of day and night. The second objective we are going to handle here when we talk about the Earth's orbit is it was saying that we should know that the Earth orbits the Sun once in approximately 365 days, and we should use this to explain the periodic nature of the seasons. Okay, so let's talk about the Earth's orbit. So the Earth orbits the Sun once approximately 365 days. In other words, the Earth makes one complete revolution around the Sun, just like other planets move around the Sun. But this takes approximately 365 days, and this is what we call the Earth year or the year. So a year is approximately 365 days, and that is the time it takes for this for the Earth to orbit or to move around the Sun. A year is approximately 365 days, and that is the time it takes for the Earth to orbit around the Sun. And this orbit around the Sun could be together with the tilt of the Earth or the orbit of the Earth around its axis or the Earth's tilt is going to create what we call seasons. So the combination of the orbiting of the Earth around the Sun and the Earth's tilt creates this what we call the seasons. So the seasons are as a result of the Earth's orbit or Earth's rotation around the Sun and its tilt about its axis. Remember, the Earth orbits about its axis once every 24 hours, and its axis is tilted from the vertical at an angle of about 23.5 degrees. So the combination of the orbiting of the Earth around the Sun and the Earth's tilt creates what we call the seasons, or is responsible for what we call the seasons. So the time taken for the Earth to make one revolution around the Sun is approximately 365 days, or simply 1 year. And the seasons are as a result of um, this orbit around the Sun and the Earth's tilt. That's why we have seasons changing throughout the year. So this diagram here illustrates what really happens during the seasons. So this is a complete cycle of the Earth about the Sun. For example, let's start with this position here around 23rd of September when the Earth is here. Um, from autumn towards December, we are heading towards winter. And I want you to just look at the axis here. So as the Earth spins, of course, about its axis, some parts of the Earth will face the Sun, and some parts of the Earth will not really be facing the Sun. But remember, it's also spinning about its axis. So as the Earth moves around the Sun, because of its tilt about its axis, for example, this part here is far away from the Sun, and therefore that part may experience winter, and this part here, which is closer to the Sun, may actually be not experiencing winter, or it may not be as cold as the other part. So then we move towards winter, and during March, there are these parts which are very close to the Sun that will be experiencing much heat, and there are those parts which are far away from the Sun that will be experiencing much cold. And so the cycle continues until um, another cycle repeats, that is after 1 year. So the combination of the Earth's tilt and its orbit around the Sun is going to be responsible for us to observe the seasons such as summer, autumn, winter, spring, and so on and so forth. So details of how the seasons come up is not really part of this syllabus. Here I just want to give you a simple tip, a simple clue on what this orbit around the Sun and the tilt result into creating the seasons that we observe throughout the year. So it's the sun's orbit around the sun. I mean, it's the Earth's orbit around the sun and the Earth's tilt which are responsible for creating the seasons. So I have just mentioned that the seasons in the northern hemisphere are created by the tilt of the Earth, and its orbit around the sun, as we have just illustrated, or we can even illustrate here. It's the tilt of the earth is It is the tilt of the earth and its orbit around the sun which are responsible for the seasons. So when you look at this diagram, you can see what happens during autumn. Look at the northern hemisphere. If we divide the earth into two parts, just look at the northern hemisphere. Remember, this part here is not the same as the other part, because this part will be very close to the sun compared to the other part because of the tilt. Look at what happens in December. Look at this part of the earth and compare to the other part of the earth. So there's this part here which is in the southern hemisphere, and there's the other part here which is in the northern hemisphere, which will be completely cold, and the cycle continues. So uh, in position A, that is, we are starting with December. In the month of December, the southern hemisphere, because the southern hemisphere is closer to the sun, the southern hemisphere is going to be summer. And in the northern hemisphere, because it is far away from the sun, that is going to be winter. Then in March we have this. Remember, the Earth is moving around the sun. In March, the southern hemisphere is going to be autumn, that is fall. So we have started moving away from the sun. So the southern hemisphere has started moving away from the sun, but of course it is just turning to spring in the northern hemisphere. During June, I think during June, we now when you look at the southern hemisphere is far away from the sun. Now it should be in winter, and the northern hemisphere has already started approaching the sun, so it should be turning to summer. And then again in September, uh, the northern hemisphere is has started moving away from the sun, and therefore it is going to be spring. And the northern hemisphere is going to the northern hemisphere has started moving away from the sun, therefore it is going to be autumn. And the southern hemisphere has started moving closer to the sun, so it is going to be spring, and the cycle continues, and so on and so forth. If you want details of how seasons are formed, you can do some research on the internet. It's not really part of details of how seasons come up is not really part of the syllabus, but it's because of the orbit of the Earth around the Sun and its tilt, which leads to seasons, especially in the northern and southern hemisphere. Of course, we don't have seasons at the equator for some reasons. So, countries at the equator, especially African countries, which I'm very much familiar with, do not experience such seasons of autumn, spring, I don't know, winter. So, countries at the equator do not experience seasons because the sun's rays always hit them at the same angle. But countries in the northern and southern hemisphere, the sun rays do not hit them at the same angle. That's why for them they experience winters, summers, autumn, spring, and so on and so forth. Because for them, the sun's rays do not hit them at the same angle. But of course, countries which are the equator, they do not experience such seasons because the sun's rays always hit them at the same angle. What do we mean by the equator? The equator is an imaginary line drawn around the Earth halfway between the North Pole and the South Pole. So if this is the Earth, that imaginary line drawn halfway between the North Pole and the South Pole is what we call the equator. So countries which are very close to the equator do not experience seasons because the sun's rays will always hit them at the same angle. But countries at the North and the South Pole, remember, if we draw in the tilt, the axis, countries which are somewhere here and these ones here do not, the sun's rays do not hit them at the same angle. That's why in the northern hemisphere and the southern hemisphere, they experience what we call winters, summers, and so on and so forth. So the equator is an imaginary line drawn around the Earth halfway between the North Pole and the South Pole. So the seasonal differences are more apparent, and the farther from the equator you are. So as you move far away from the equator, then the seasons are going to be extremely different because of the different angles at which the sun's rays hit those different places. And I have a picture of Alaska in midsummer, and this is how it looks like. Because for it is because it is located in the northern hemisphere, this is how it looks like at 2 p.m., 8 p.m., at midnight, and at 4 a.m. It's almost the same. These are hours before and after midnight in Alaska in midsummer. Remember, Alaska is in the northern hemisphere. So there is a difference in the seasons as you move far away from the equator. I think Alaska is about it's around 4,000. It could be around 4,070 kilometers north of the equator. So it is located in what we call the northern hemisphere. Okay. So here is a class activity that I normally do for my students, and I'll do this for my students. This is the only thing I do in class when it comes to this topic. I just do this activity. I don't really want to teach this in class. My students should watch the videos or do research of this topic. So if you're a teacher and you are watching this, you can perform this activity to your students in class. Use a lamp to represent the sun and a ball with a rod through it to represent the earth. So mark your position on the earth using a piece of modeling clay. You can just use a marker. Then in a darker room, hold the earth near the sun. When I put quotes, it means it's just a model, and the sun, and turn the earth on its axis to model day and night, which is very easy. So you just rotate the ball so that one end of the ball will be facing the lamp, which will be day, and the other end will be in the dark part, which is going to be night. Then you can try to tilt the ball, which is acting as the earth, on its axis, and investigate the seasons by moving the earth around the sun. So you try to move the ball. After tilting, you now move it around the sun so that students can be able to see the angle at which the sun rays are incident on different parts of the earth. So you can now investigate the difference in seasons between the south and the northern hemisphere. So that is a simple activity which you can carry out in your classroom. Let's talk about the moon and the earth, and we should focus on what we call the phases of the moon. So the moon and the earth. What do we mean by the moon, or what do we know about the moon? This animation shows what the relationship between the earth and the moon, or our moon, which orbits our earth. Remember, the earth continues spinning, but the moon also moves around the earth. So the moon is considered to be a natural satellite around the earth. The moon is considered to be a natural satellite. It's natural satellite around the earth. So the moon travels around the earth in roughly a circular orbit. It is just roughly a circular orbit once a month. So the time taken for the moon to move around the earth in a circular orbit, or in approximately a circular orbit, is once a month, or it's 1 month. And we consider 1 month to be approximately 27 to 28 days. So 1 month is approximately 27 to 28 days. So we say that the moon orbits around the earth approximately in 27 days or 28 days. That is actually 1 month. So the moon revolves around its own axis in a month, so always has the same side facing the earth. So the same side of the moon is always facing the earth because it moves around its own axis in 1 month. The same side of the moon is always facing the earth. So we never see the other hemisphere. We never see the hemisphere that is always facing away from the moon, apart from astronauts. Although astronauts have orbited the moon and artificial satellites have photographed it, for us on the Earth's surface, we never see the other side which is always facing away from the Earth. We always see that side of the moon which always faces the Earth. And by the way, the moon is a rocky sphere which we only see when it reflects light from the sun. So the moon is not a source of light. It is not a luminous object. It's not a luminous body. It doesn't produce its own light. So we only see it when it reflects light from the sun. So the moon is only visible when it reflects light from the sun, which means during what we call a total solar eclipse, where the earth comes between the sun and the moon, we may not see the moon. And therefore we may have what we call a full moon. We may have what we call a full moon, but a full moon, of course, is only seen when a full moon is only seen when there is no total solar eclipse. But when there is total solar eclipse, when the Earth comes in between the sun, when the Earth comes in between the sun and the moon, it means the shadow of the moon is going to be the shadow of the Earth is going to be covering up the moon. We don't actually see it. But if that is not happening, we see a full moon. So the moon is a rocky sphere which we only see when it reflects light, which is coming from the sun. And the moon does not produce its own light, but rather just reflects it from the sun. That one is a very important point. The moon does not produce its own light, but just reflects it from the sun. And as the moon orbits the earth, the sun lights up different parts of it, making it seem as if the moon is changing shape. And these are the different shapes of the moon that we see throughout the month or throughout the 28 days, which we are going to call phases of the moon. So as the moon is orbiting the earth, the sun lights up different parts of the moon. So it makes us to get an impression as if the moon grows bigger and it grows smaller because the sun lights up different parts of the moon as the moon orbits the earth. And these different parts constitute or make up what we call the phases of the moon that we see in the night sky. So let's talk about the phases of the moon. Unfortunately, my animation is not very clear, but the second one here is very easy to see. Let me see if I can modify this animation. Okay, so the different phases, the different parts of the moon lit by the sun that we see in the night sky over a month, over about 27 days or about 28 days from the earth, are what we call the phases of the moon, which we call the periodic cycles or phases. We call them simply phases of the moon. So these animations are illustrating what I really want to demonstrate with the phases of the moon. For instance, when you look at the moon, just look at how the moon behaves when it is moving around the earth. Remember, as it is moving around the earth, different parts of the moon are being lit up by the sun. So if you're on this earth's surface, you will see different parts of the moons. For example, when the moon is here, you would see, I think this animation would have been the best, but is not visible. So when the moon is here, when the moon is in this position here, we see that the parts of the moon which are being lit go on changing as the moon moves around Earth. This animation was corrupted. I don't know why, but we can see the different parts of the moon which are seen as the moon moves around the Earth. And these different parts of the moon which are seen as the moon moves around the Earth are what we call phases of the moon. If the sun is the other side, if the sun is this side, it means here we would see what we call a full moon, which is not going to be visible to the observer on the Earth's surface, unless when there is a lunar eclipse, where we shall see just a ring around the moon. And as the moon moves, the part of the moon which is being lit up by the sun, as observed by an observer on the Earth's surface, grows bigger, and it becomes bigger when the moon is in this position here, where we shall see what we call a full moon, and then it starts becoming smaller, and the cycles continue. So I think this animation here is what is representing what is happening to the moon. So in this position here, we have what we call a new moon. Here we have a new moon. Of course, it means the sun is this side. The sun is this side. So that means the shadow starts increasing. It starts increasing. And when the moon is in here, we completely do not see it unless there's a total lunar eclipse where we just see a ring around the moon, and that is called a full moon. Of course, when the sun is the other side, here we see what we call it. Here we have a new moon. Here we have what we call a full moon. Okay. So the phases we observe at any time depend on where in the sky the moon is relative to the sun. This varies as the moon slowly orbits the Earth once every about 27.3 days. 27.3 days. And as the moon revolves around the Earth, we see different amounts of the illuminated moon. Sometimes none of the lit part faces the Earth. That's when we have the new moon. For example, if the moon comes between the sun and the Earth, it means the part which is lit is facing the sun. So for us, we only see a ring around the moon if there is total lunar eclipse. If there is no total lunar eclipse, we completely don't see the moon. And the other times, all the lit part faces the Earth. So this is this part here. When the part which is being lit is facing the Earth, we see a complete circle which is called a full moon. And this is what we would see when we have what we would see when we have a full moon. But then as days start going, the full moon now starts decreasing. So we say it is waxing, and then after we see a new moon starts, then we say it starts waning. Only that this animation only shows waxing up from the full moon to a new moon. But this animation which is corrupted, if you have download my slides on your computer, I think this will be showing very clearly. So the moon moves counterclockwise. I think these animations are all showing that the moon moves counterclockwise. That is very important to note. And as the moon moves around from a new to full, we see more and more. That means the moon is waxing. And then as it continues from the full back to new, we see less and less. So we say the moon is waning. So we have a waxing and waning. We have a full moon and a new moon. Okay, so let's understand these phases of the moon in more details. So initially, we can see if a new moon, if there is total lunar eclipse, we can see a new moon where it will just be a ring around the moon, simply because the side of the moon which is facing the sun is we are in the shadow of the moon. That is during the new moon. We can't see the side which is being illuminated by the sun apart from when there's a lunar eclipse where the moon is perfectly in line with between the earth and the sun, where we just see a ring around the moon. That is called a new moon. Now as the angle starts changing, we see a waxing crescent which is like a smile. The moon now starts growing. It starts becoming bigger. That means more and more part of the moon which is being lit or being illuminated by light, as seen by an observer from the earth, starts becoming bigger. Then we have what we call the first quarter. In the first quarter, the person on the earth sees a quarter of the moon because half of the moon is illuminated, but the person on the earth's surface only sees a quarter. That's why we call the first quarter of the moon. Then now the moon grows beyond the first quarter. The person on the earth's surface sees more than half of the quarter of the moon which is being illuminated. That's what we call a waxing gibbous. Then after, we now see a full or a complete full moon because the whole side, the whole half of the moon which is being illuminated by light from the sun is facing the earth. So the person on the earth's surface will see a full moon. So we have moved from the new moon, waxing crescent, first quarter, waxing gibbous, and then the full moon. After that, now the moon starts to grow, becoming smaller. Then again, we say the moon is waning. uh, the size starts becoming smaller, so we have what we call the waning gibbous. The person on the Earth's surface sees less than a full moon, less than a full circle of the moon, because less than a full circle of the moon is facing the person on the Earth's surface. Then again, the person sees the last quarter of the moon. The person on the Earth will see quarter of the moon because half of the moon is being illuminated by the sun. Half of the moon is being illuminated by the sun, but only a quarter is seen because the other half, which is illuminated by the sun, is not facing the person. It is facing some away from the is facing at an angle of 90 degrees from the person. So the person on the Earth's surface only sees a quarter of the moon. Then we see the waning crescent, which is like a smile. And again, we come back to the full moon. So that is, those are considered to be the phases of the moon. Here is a video for the rap song to remember the phases of the moon for the 27 days. So the outer circle shows how the moon looks like from the Earth at various positions. So the circle which I've indicated here is showing how the moon looks like from the Earth, or when observed from the Earth at various positions. And when we talk about waxing, we mean light is being added and the moon is looking bigger and bigger each day. And after the full moon, we have what we call waning, the waning gibbous, the last quarter, and the waning crescent. Here, the light is going away and the moon appears to be shrinking each day or every day. That's what we call the waning gibbous and the waning crescent. So you can watch the rap song, which is very interesting about the phases of the moon, ranging from the new moon, waxing crescent, first quarter, waxing gibbous, full moon, waning gibbous, last quarter, waning crescent, and then back to the new moon. But I will explain some of these in more details here. So let's start with the new moon. What is really happening during the new moon? So for an observer on the Earth's surface, what do they expect to see in the new moon? So if we are in a new moon, like I said, it is either not visible, and if it is visible, we just see a ring around the moon because there is a lunar eclipse. There is an eclipse. Sorry, I think we call it a solar eclipse. So for the new moon, the uh, the moon is between the sun and the earth. The side of the moon that is lit up or that is illuminated is facing the sun, and the darker side of the moon is facing the earth. So for you, an observer who is on the earth, you will not see the moon unless there's an eclipse, which is called a solar eclipse. So the moon is not visible to us except during a solar eclipse where we see a bright ring around the moon. So it is called a solar eclipse, not a lunar eclipse. A lunar eclipse is when the earth is between the sun and the moon. So we cannot see it because we are looking at the half of the moon that is in the shadow. That is for the new moon. Then we have what we call the full moon. The full moon is here. The full moon. So we are able to see the full moon because the earth is between the moon and the sun. However, the shadow of the earth is not completely is not obstructing the moon. The moon is illuminated side. The moon's illuminated side is facing the earth. That is during a full moon. The moon appears to be completely illuminated or lit up by direct sunlight and appears like a complete circle. It appears like a complete circle. This cannot be seen during total lunar eclipse. If there is a total lunar eclipse, it means the shadow of the earth will cover up the moon. In that case, we don't see the moon. But if it is not a total lunar eclipse, then the full moon can be seen as a complete circle. That is the full moon. Then we have other stages in between there. For example, after the new moon, we have the waxing crescent, which looks like that smile. Here, the moon has started growing in size. The moon appears to be partly but less than one half illuminated by direct sunlight. The fraction of the moon's disk that is illuminated is increasing. During this phase, the right side of the moon is illuminated and resembles a smile. That is when we have the waxing crescent. Remember I said waxing means the moon is becoming bigger each day, and the side which is illuminated is increasing, or more light is more of the moon is being illuminated, so it is becoming bigger and bigger each day. Then from the waxing crescent we have what we call the first quarter. The first quarter looks like this. We call it first quarter because for us on the earth's surface we see a quarter, but it's actually a full half which is facing the moon, facing the sun. So here one half of the moon appears to be illuminated by direct sunlight. The fraction of the moon's disk that is illuminated is increasing. For us on the earth's surface, because we see the moon at 90 degrees, we see only a quarter of the moon. Then next we have what we call the waxing gibbous, which is bigger than a quarter. So here again the moon appears to be more than one half, but not fully lit up by direct sunlight. The fraction of the moon's disk that is illuminated is again increasing. Of course, after the waxing gibbous, that's when we move to the full moon that we have already seen. But then after the full moon, now the moon starts waning. It starts becoming smaller. So we have what we call the waning gibbous. After the full moon, we have what we call the waning gibbous. The moon starts becoming smaller in size, or the side which is being illuminated starts becoming smaller. So the moon appears to be more than one half, but not fully illuminated by direct sunlight. The fraction of the moon's disk that is lit up is decreasing. After being full, now the moon is shrinking in size. It is more than halfway lit, but now the right side appears dark. So the right side which was lit up is now appearing dark in this case after the full moon. Then after the waning gibbous, we now have what we call the last quarter. Remember, it is now the left hand side which is being lit up, and the right hand side is dark. So for us on the earth's surface, we see a quarter. We see a quarter of the left hand side which is being lit up. So in the last quarter, one half of the moon appears to be illuminated by direct sunlight. The fraction of the moon's disk that is lit up is decreasing. During this phase, the entire left half of the moon is illuminated and the entire right half is dark. We are getting closer to the new moon. But remember, for us on the earth's surface, we only see a quarter because we are seeing the moon at 90 degrees. So we see a quarter. Then we have what we call the waning crescent, which is also looking like a smile. So in this phase, the moon appears to be partly but less than one half illuminated by direct sunlight. The fraction of the moon's disk that is illuminated is decreasing, opposite to waxing crescent. The left side of the moon is illuminated and resembles a smile. Of course, after the waning crescent, now it is the new moon, which is only visible if there is a solar eclipse, a total solar eclipse, where we see a ring around the moon. But if there is no solar eclipse, that is, if the moon is not directly in between the sun and the earth, then we don't see it completely. We don't see the full moon. We don't see the new moon if it is not completely between the sun and the earth, or if there is no total solar eclipse. So here is a self-check. Copy and complete the following sentences. A day is the time taken for dash. A month is the time taken for dash. A year is the time taken for dash. I think if you have been following these videos, you will notice that a day is the time taken for the earth to spin about its axis. And then a month is the time taken for the moon to orbit the earth. And a year is the time taken for the earth to orbit around the sun. So the earth is tilted on its axis, and this causes, of course, the tilt of the earth on its axis causes what we call seasons. which do not occur at the equator, because at the equator we said the sun rays are incident onto the earth at the same angles. Explain why it is summer in the northern hemisphere when it is winter in the southern hemisphere. Of course, here you must be looking at the tilt of the earth and the rotation of the earth about the sun. How many days are there from one full moon to the next? So that is one complete month. That is 1 month, which is about 27.23 days, or 27 days, or 28 days. That is one complete month. Okay. So here is a self-check. How can you tell it is night time at point X? So you should be able to answer that question. Redraw the diagram to show where point X will be after 12 hours. So after 12 hours, that is half of a day. Remember, it takes 24 hours for the Earth to spin about its axis. The moon does not emit light. Explain how one is able to see the moon. We have answered that question. Name the force which keeps the moon in orbit around Earth. Of course, that force is gravitation. Gravitational pull or gravitational attraction. Let me just write gravitational attraction rather than gravitational pull. Describe the movement of the moon. I've already showed the motion of the moon. A ball dropped on Earth will fall faster than an identical ball dropped on the moon. What does this tell you about the moon's gravity? Of course, the Earth's gravity is going to be higher than the moon's gravity. So you can say the moon's gravity is very weak compared to the Earth, to the Earth's gravity, and so on and so forth. I will not answer all the questions for the self-check. The diagram shows how people 1,000 years ago thought the solar system looked. State one way in which this model is different from what we know about the solar system. State one way in which this model is similar to what we know about the solar system. Of course, our next part is going to be the solar system. And I think I misplaced this question here. I should have placed it under the solar system, but that is very fine. Let's meet in another topic. I mean, in another chapter, in another part of space physics.
It's kind of funny that the more we last, the more we set the